do this is I would recognize that rule right here. If I have, let me just make a rule for you. Let's just call that m, let's call that x in the end. And I'm going to say this is equivalent to x to the power over root, n over m. Just remember, roots in the bottom like trees, right? So I'm going to try to rewrite this radical form in a rational form. It'll make it look much easier, okay? Would you guys agree that this part right here can be written as power over root 14 divided by 2?
Yeah.
It's x to the 7th.
Yeah.
Now I'm feeling pretty good. So when I rewrite the left, I have the 4th root of x to the 7th. We should break out of jail. If you wrote that, I probably said okay, but it should be simplified further. So I could write this, or, how many times is 4 going to 7 evenly? Once. 1x hops out of jail, 4th root, how many remaining?
3.
Okay, that's another way to write it, technically a little bit cleaner. And I have one other method, is I can just leave it power over root, x to the 7/4. Now, when you get into like calculus and stuff, a lot of times you work with these, rational exponent form, but the final answer usually looks cleaner like this. But any one of those three is actually correct. Okay? Let's see here. We have x plus 1 over x squared plus 5x plus 6 minus x plus 2 over x plus 3. This was not set equal to anything, so I couldn't just multiply through by something. It's merely you're simplifying an algebraic expression. Okay? So the first thing I would always do is factor. Okay, now we had a pretty nice one, just to get the idea, and I did this on purpose so it wasn't that bad. Can you factor x squared plus 5x plus 6? That is correct. So if you look at this and realize it's x plus 2, x plus 3, now I'm looking for a common denominator. Okay? Now remember, if you can't think of anything clever, simply multiply them together. And you can do that. But right now, I bet we could agree that this would go into this many times, and of course this goes into itself. Okay, so this one's really not that of a bad one. So if I write x plus 2, x plus 3, I'm going to leave it like that. I'm going to put that negative sign right there. I'm just going to go like this so I don't make a mistake in a second here, okay? So, would you agree I can say this quantity goes in here how many times?
X plus.
Wait. Well, this is the same thing, right? We kind of borrowed it. This goes in this once. So 1 times this is just x plus 1. Now, what you were just saying is absolutely right for this one. How many times is this going to this?
X plus
X
2
plus
times.
2 times. So I can write it like this. We can clean it up in a second, but we get the right idea, right?
Yeah.
Now, I'm just going to look at it as x plus 2 squared, but if I say x squared plus 4x plus 4, you guys would agree with that, right? Same thing. But now I got to remember, this is technically a negative 1 distributed to this quantity in the brackets. Okay? So I'd have a negative x squared, a minus 4x, and a minus 4. Does that make sense? I'm just going to erase and plop that right back in. So if I have, well, yeah, I don't want to. So let's combine like terms first, and I'll put the whole thing back there. This is a negative, this is a negative, this is a negative now, right? So let's see, I have a negative x squared. I have a negative 4x plus 1x, is that negative 3x? And I have a negative 4 plus a 1, is that negative 3? All over x plus 2, x plus 3, and you're done. Okay? If you wrote this as x squared plus 5x plus 6, completely fine. It doesn't matter. And later on when we graph crazy things with asymptotes and all this, I would leave it factored. But either way is fine for probabilities. Okay?
I had the top part.
You okay? Tell me. You good?
Yeah.
Okay. So, not as bad as you thought here,
I
right?
don't know how I even did it.
Okay. Is this still taping okay or no?
Yep, we're at 19 minutes.
Okay. All right. I'll try faster. So if I have 5x squared equals 4x minus 2, and it has an equation, an equal sign, I know it's going to be a solving, right? But I know for a quadratic equation, I need it set equal to?
0.
0. So I could move this over here, but I find it way easier to keep a positive leading squared coefficient when I can. So I'm going to minus 4x over, I'm going to add 2 over, and then I'm just going to do quadratic formula for now. Okay? Who remembers what it is?
Negative b.
Negative b plus or minus the square root of what?
B squared.
There we go. So you have b squared minus what?
4ac.
Okay. See? You guys know this stuff. All over 2 times a, don't put 2 back. So I have something like this. When I go to plug stuff in though, a very common mistake, what happens if it's a negative? Turns into a positive, negative, negative, positive. So I have x equals 4 plus or minus the square root, oh, sorry, where was that? There we go. And what do I put here? 16. Now I'm going to put that negative sign right there, or subtract. Now, I do it this way. I'm just going to take out the 4ac, just so I don't make a mistake. My a value is 5. My c value is 2. What does that give me? 40? So I put a 40 right here. I definitely get a negative. What's 16 take away 40? Negative 24. Now I have 4 plus or minus the square root of negative 24 over 2 times a being 10. But I got a lot of stuff to do to that. Not only does it have a negative in the radical, it also can be reduced, right? Who thinks they know what root negative 24 is? Right. 2i root 6 would be the cleanest way, but you guys mostly said it. So just remember, if you got stuck, and I looked at negative 24, I'd say negative 1, root negative 1, root 4, root 6. That's where they got the I, the 2, and the root 6. Okay? So I'm going to write this out and say 4 plus or minus 2i root 6 all over 10. And I'm going to stop and look at it for a second. I noticed some of you made a very similar mistake. You do it quickly, and I know there are tricks, but I tend to just go nice and slow to really see it. What can I factor out of the top?
2.
A 2. And you guys, I know what you're doing. You're looking for little shortcuts, but you make little mistakes sometimes. So if I take out a 2, I get a 2. I get a 2 plus or minus I root 6 all over 10. Now if I write it like this, let's double check. 4, blah, blah, blah. We're good, right? I can reduce the 2/10 only. Some of you keep doing weird things like this, but once I take this 2 and the 10, I get a 5, and I'm done. 2 plus minus I root 6 is done. Okay? And one more problem, and we're done. Okay.
What are you doing for the rest of class?
Learning about maximization formulas.
Wait, I have a question.
Yes.
So if you had like 4 plus 3i all over 10, can you?
There's nothing you could do in that case.
Okay.
That's a good question, but yeah, nothing you could do. It has to be in common. So if I have the absolute value of 7x minus 1 greater than or equal to 3, there are 2 possibilities. Remember, absolute value are tricky. They just want a lot from you for one problem. I'm going to say 7x minus 1 is greater than or equal to 3. And I'm fine with that. But it's a kind of a double trickaroo here. Then I have 7x minus 1 is
I know what I did wrong. It's
less than
That's what I did
or
wrong.
equal to negative 3. That's what got half you right there, I think.
Yeah.
Okay? Now, as I do this math out, you're all going to be completely fine. If I add 1, I add 1. 7x greater than or equal to 4. Oh, is that you guys?
Yeah, we can wait.
No problem. You guys can go. The video's taping. It's fine.
Yeah.
Not a problem. We're done right now anyway. So that's it. Show me and I'll look at it with you. If I made a mistake, I'll fix it.